Okay, so last class you have seen normal form. What is normalization? Then what do you mean by a relation is in a normal form? Then the first normal form. How? What are the different methods for achieving first normal form? Okay, those things. So basically, normal form says that when you are going to normalize a relation, you may have multiple fragmented relation. That means one relation may have multiple other relations in which it gets fragmented. Okay, so what was the first thing? The first normal form said that every attribute should have non-atomic value. Okay, that means one under one tuple and one attribute you cannot have multiple values stored at a as a single value. Okay, that means you have to store in every row every attribute the value should be non-divisible. Fine. So in order to achieve that, you are having three options: strategy 1, 2, and 3. One was getting you redundancy. Strategy 2 was getting you null values. Strategy 3 was proper. Okay. So if you remember that, with that concept, we'll go to normal form 2. Okay. Second normal form, or 2NF. 1NF, 2NF, 3NF, likewise. Fine. So let me present. Yeah. Uh, can see the screen.
Yes, sir.
Fine. So second normal form, the definition is a relation schema is in second normal form if every non-prime attribute in R is fully functionally dependent on the primary key. Now, if you remember full functional dependency, the second normal form is based on full functional dependency. Full functional dependency means what was that? Anyone remembers full functional dependency?
So if an attribute has a functional dependency on another, and if that is an attribute set, then no attribute from that set can be removed.
Can be
Or
removed.
say a single attribute would not have functional dependency with the other one.
Oh, okay. That means from a functional dependency, the uh, deciding side or the x side or the left side is indivisible. That means there is no redundancy in that. If you can remove some attribute from that, then that is partial functional dependency. That means the dependency of y on x is partial. But if you cannot remove any attribute from x, that means that is full. The dependency is on all the attributes present on the x side. Okay, so that was your full functional dependency. Fine. So that concept is there in second normal form. That means every, it says that every non-prime attribute, that means y if it is non-prime attribute, it should be fully functionally dependent on primary key. That means the x side is said to be a primary key. We'll see there is an alternative definition to this. The normal definition is this one, which says that every non-prime attribute A in R is fully functionally dependent on primary key of R. That means non-prime attribute means it is not part of any key. Okay, see one example here. You might not have seen this notation before. Here FD1 means function dependency 1, the first function dependency. This is a given relation. Assume that this is a single relation in your database. It has these 6 attributes. SSN and P number combinedly are the primary key. Hours, ename, pname, p location are other attributes. In this case, I will say that these two are my prime attribute because these are combinedly called as primary key. These 4 are non-prime attribute. Okay, because they are not part of any of the key. Fine. Now this is function dependency 1, which says that SSN P number determines hour. This is seen like this. Okay, uh, you have to represent it is it will be represented like this. SSN P number determines SSN P number determines hours. Okay, this is your first functional dependency, FD1. Okay, you see here FD1 is SSN P number determining hours. Similarly, FD2 is SSN determining ename. Okay, it will be given like this, or this figure may be given. Anything. If directly it is written like this, then you have to. It will be better if you draw a figure like this one. SSN determines ename. Okay. Similarly, FD3. Sorry. FD3 is P number determines P name and P location. P number determines P name, P location. Okay, these 3 are the function dependencies set given for this relation. You can represent it in terms of this figure also. Now, first thing is before going on to 2NF, you have to say that this is conforming to 1NF. So tell me whether this is in 1NF or not. How to know it? Before going on to test whether this is in 2NF or not, you have to check whether this is in 1NF or not. 1NF says that every attribute value present in the relation is non-atomic. Sorry, atomic. It is not dividable. So there is no value given in this relation. Only this schema is given. If only schema is given and no data is given, that means you assume that this is in 1NF. Okay. If data would have been given and it is not in 1NF or in 1NF, then you have to do something. But if no data is given, only schema is given and said that normalize it into 2NF if it is not in 2NF already. So in that case, you have to assume that there is no data, means it is already in 1NF. Fine. Now you go for 2NF. What 2NF says? Sorry. 2NF says a relation schema R is in second normal form if every non-prime attribute A in R is fully functional dependent on the primary key. That means every non-prime attribute, see the cursor, every non-prime attribute in R is fully functionally dependent on primary key of R, dependent on the primary key. Okay, which is the primary key here? Which is the primary key here? These two combinedly? Yes or no? So here hours is a non-prime attribute which is dependent on both. Dependent on both means that is full functional dependency. But here ename is a non-prime attribute. This is dependent only on SSN, not on P number. Okay, this thing is not allowed in 2NF. It says that if a non-prime attribute is dependent, is involved in a functional dependency, then it should be involved with both the attribute or all the attribute present in the primary key. Here both are combined in the primary key, but this is dependent only on SSN. So this is not allowed. In this case, ours is a non-prime attribute, but this is dependent on both. So this is full functional dependency. FD1 is full functional. FD2 is partial functional dependency. This partial functional dependency is not allowed. Okay. Similarly, this one, P name, P location is dependent only on P number, not on SSN. So FD3 is also not allowed because this is also partial functional dependency. So when a relation is given with the functional dependency set, you draw a figure like this, draw the arrow likewise. This is full functional dependency you got, this is partial functional dependency you got, this is also partial functional dependency you got. So you have to fragment the relation in such a way that this partial functional dependency will become full functional dependency somehow. So how do you do that? Using this technique. In 2NF normalization, what you do is that keep the full functional dependencies as it is. This was not having any problem. SSN pin number hours, they can be kept. Hours was full functional dependent on pin number and SSN, so this is fine. Okay, but this one which was diverging from the uh, rule ename, that is fd2 and fd3, so you have to reduce it into separate relation, you have to create separate relation from them. So ename, it was dependent on ssn, so take them together to another table. Okay, ssn and ename, they were dependent, no, ename was dependent on ssn only, so take them out, keep it in a separate relation where ssn will be the primary key as it was here. Here also ssn will be there, it has to be there in all the tables, sorry, in wherever it is required. Okay, so ename was determining, name was dependent on ssn, so this was brought onto a separate table. Okay, this is fd2. Fine. In fd3 what happens, p name and p location are dependent on p number only. Fine. So p name, p location are dependent on p number, so you take them out and made a separate relation. Fine. In that relation, p number was designated as the primary key. Okay, because whenever you are drawing a schema, you have to draw the uh, which are the primary key of that relation, you have to mark it. So in this case, these two were combined in the primary key. I decomposed this into 3 different tables in order to attain 2NF, because this was not in 2NF, because you are having FD2 and FD3 which were violating the norms of 2NF because they are partial functional dependent. So you remove those attributes onto separate table. Ename was taken onto EP2 along with SSN. Similarly, pname and p location are taken into EP3 from this relation. Now these three, you see whether these three are okay or not. What the 2NF said, that any non-prime attribute is full functional dependent on the primary key. Yes, these are primary key and this is full functional dependency. Now this is also non-prime attribute which is dependent on only on SSN. So this is also full functional dependency because there is no way you can divide this any further because SSN is a single attribute. In this case, there are 2 attributes, so you have to check whether they are full or partial. Okay, in this case, this is automatically full functional dependency. Similarly, this one also, this is automatically full functional dependency. So these 3 combinedly are now in 2NF. Okay. Any issue in this? This was your 2NF. Fine. The definition again, you see a relation schema R is in second normal form if every non-prime attribute A, means wherever you are having a functional dependency where non-prime attributes are involved at the y side, it should be on the x side, there should be full functional dependency on the primary key. Okay, the primary key are if the x side always involves primary key or some key, that will be fully functional dependent. Fine. This was one example. Let's see another example here. Yeah, this will come after this one. Yeah. So that definition which I showed, this one, this is normal definition of second normal form. Okay, that means you can write it. There is an alternative definition to second normal form. Okay, which says, is it visible? A relation schema R is in second normal form if every non-prime attribute A in R is not partially dependent on any key of R. In the previous definition, what it said? You see here the previous definition of second normal form. It said on the primary key of R. Rest things are same. Schema R is in 2NF if every non-prime attribute A in R is fully functional dependent on the primary key of R. So that was on primary key. But there is an alternative definition which you can also uh, take into account. That is, not partially dependent means full functional dependency. So every non-prime attribute is full functional dependent on any key of R, not only primary key, on any key. Okay. In the previous definition, since it was introduction, it said it is on primary key of R, but actually that is on any key of R because key is key. Okay. See an example here for that. You see there is another relation given. Here property ID is the primary key, only a single primary key. County name and lot number is a candidate key. You know the difference between primary key and candidate key? I hope you remember. Candidate key means this is also a candidate for primary key. That's why the name is candidate key. This is also a candidate for primary key. So initially when the designer designed the attributes, he made two candidates. One is this one as the primary key or this one as the primary key. But finally this one was chosen as the primary key. So this one became primary key. This one was left as candidate key. But this is also having the potential to become the primary key. Fine. So in this particular relation, I will say that this is a prime attribute, this is a prime attribute, this is a prime attribute. These three are non-prime attribute. Okay. First, you have to identify that thing, that which are prime and which are non-prime, because the definition says that every non-prime attribute should be full functional dependent on the primary key or any key of R. So how many dependencies are there? FD1, FD2, FD3, FD4. 4 dependencies. Now you have to check that which functional dependencies are full functional and which are partial functional. Tell me what will be FD1's case, whether that is full functional or partial functional. FD1. Anyone? FD1 will be a full functional dependency or partial functional dependency. What happened? No one is responding.
Full functional.
Hmm?
Full functional.
Full functional. How?
Because all the attributes are depending on only property ID, which is a key.
Yeah. This is a primary key and there is single attribute here. You cannot divide this further. So there is no worry of whether it is a partial or full, because you see this arrow means these are dependent on this one. In the previous case, if you see with the previous case, this represent this one. Arrow is here means our is dependent on this two. Ename is dependent on SSN. Like here we wrote ours is dependent on SSN and pin number. Okay. Ename was dependent on SSN. Okay. Similarly, in this case, tax rate, price, area, lot number, county name, all are dependent on property ID, which is indivisible. So this one is full functional dependent. Okay. Now this is according to the rule of 2NF or not. 2NF says that every non-prime attribute, here you forget about this two because these are prime attribute. You have to only take care of these three. Every non-prime attribute should be full functional dependent on primary key. Okay. These two are candidate key. This is already a primary key. So remove this one. Yeah. So every non-prime attribute, these are all non-prime attribute, they are full functional dependent on the property ID. So this is fine. Now consider this one, whether this is okay or not as per 2NF. FD2, this is full functional or partial functional? Anyone? Is it difficult? Getting difficult, or normalization part is important, so we can have more time on this if you are not getting. But make sure you are getting it. You can't go away with normalization. You have to have clear idea about normalization. What's the problem? This one is okay. It said that every non-prime attribute, which are non-prime attribute? Non-prime attribute means which are not part of any of the key. This is lot number, county name are part of candidate key. So these are prime attribute. This is itself the primary key. So this is also prime attribute. Rest things are these three. These are not part of any of the key. So these are non-prime attribute. Fine. So these non-prime attributes, whether they are, now you have to check whether they are full functional dependent on the primary key or partial functional dependent. Here the primary key is a single attribute. So there is no way of getting if that is full or partial. That will be automatically full. Okay, because all are dependent on this one. So this is a full functional dependency. But in this case, county name, lot number is determining area, price, tax rate, and property ID. Fine. But property ID is a prime attribute, so no need to check. This is Y side. Yep. So property ID is a prime attribute. So if it is dependent full or partial, that doesn't matter. You have to check off the non-prime attribute. Non-prime attribute area, price, tax rate are dependent on both lot number and county name. So this is perfectly acceptable. Okay, these are full functional dependency again. Area, price, tax rate are dependent on both the prime attributes. Fine. The definition also said that. What it said? A relation schema R is in second normal form if every non-prime attribute A in R is not partially dependent on any key of R. Not partially dependent. So here it is not partially dependent. This is full functional dependent. These are full functional dependent on these two. On any key means either this one or this one. In this case, these were on this one, on primary key. In this case, every two, these were dependent on candidate key. Okay, that's why the alternative definition is more generalized. That means even if it is a property, a primary key or a candidate key at the left side, at the X side, the full functional dependency will be checked. Fine. Any doubt in FD1, FD2? These two are termed as full functional dependency. Now you see FD3. Here, this one is non-prime attribute. This one is dependent on county name, which is a part of the candidate key. It is not FD3 tax rate is not dependent on lot number, only on county name. So that's a problem. Okay, this is partial functional dependence because it should have been dependent on both the lot number and county name. Okay, tax rate should have been dependent on both county name and lot number to qualify as a full functional dependency, but it is only dependent on county name. So this is a partial functional dependency. Fine. So this is also not allowed. You have to reduce this in somehow to attain 2NF. Now you see this one, whether this is allowing 2NF or not. Means because of this functional dependency, you cannot say that this particular relation is in 2NF or not. So you have to reduce it somehow to multiple different tables so that you can combinedly say that these are in 2NF. This is currently not in 2NF. According to this two, these were fine. But this one created problem because this introduced partial functional dependency, which is not allowed in 2NF. Got? Now again see this FD4. A non-prime attribute is dependent on a non-prime attribute. Whether this is allowed or not as per 2NF. Anyone?
No, sir.
Not allowed or you don't know?
Not allowed, sir.
How?
Because it should be dependent on either the primary key or some of the candidate keys, sir.
Yeah, but the definition says that every non-prime attribute of A is not partially dependent on any key of R. That means if it is dependent, uh, if it is dependent on any key, it should be full functional. It should not be partial functional. It says, see the definition clearly. It says that any non-prime attribute, if it is dependent on any key of R, it should be fully functionally dependent, not partial functional. It does not say anything about dependency on a non-prime attribute. It says that non-prime attribute should be, if it is dependent on any key, it should be full functional. It does not say that a non-prime attribute cannot be dependent on a non-prime attribute. It is silent about that part. Okay, so this one is that case that a non-prime attribute is dependent on non-prime attribute. So according to 2NF, this is as yet this is fine, no problem in this because 2NF is silent on this. 2NF only says non-prime attribute if dependent on prime attributes, then they should be full functional. Like this one is prime attribute. These are all fully functional dependent. These one are non-prime attribute. These are also fully functional dependent on this one. That's why I said a dependency of a prime attribute on other prime attributes is not said in the 2NF. So no need to think of this one. You only think of the non-prime attribute, how they are dependent on the prime attributes. So this case is also getting escape in 2NF, dependency of a non-prime attribute on a non-prime attribute. So that's why when you normalize this relation into 2NF, it will be like this. FD1 was okay. Area, price, tax rate, county name, property ID, all were fine. So this was kept. Okay. You have removed tax rate because tax rate was partial functional dependent on county name. So what you did is that county name and tax rate you took it to separate table. County name became the primary number, primary key. Tax rate was now full functional dependency. Fine. And this one, since was nothing was told in 2NF, this was kept as it is. Fine. Now this two we got by dividing this particular table. And these two are now in 2NF. There is no problem in this. Fine. If it is in 2NF, how you can confirm? You can confirm by these are all say non-prime attribute. These three, oh sorry, these two. These are now full functional dependent. These are also again same full functional dependent. About this nothing is said, so keep it as it is. In this is also full functional dependence on county name, so there is no problem. So these two are combinedly now in 2NF. Fine. So you saw two examples. One is this, one is this one. Here also this was partial functional. You took it to separate table with the key this one. This one also partial functional on prime attribute or the primary key. So you p number took p number to a separate table with p name p location. These three combinedly are now in 2NF. Okay. Any doubt? No doubt from anyone? Means everybody got, or it was over the like bouncer. How many say this is concept? How many people do not understood anything? I will take separate uh, doubt class for them, particularly from 2NF. No one. Everyone understood. Still no reply.
No, I'll be honest, sir. It's a bit overwhelming for me. Like, I don't know.
Overflow.
No, it's a bit overwhelming. Like, it's a bit too much for me. Like, but if I study, like, I can get it.
No,
And
we are also going at the very slow pace. No, I am not showing you details. I am just showing you through examples. So it will be
yeah, yes, sir.
if you get
Yeah, it is. I'm just saying that it's
that,
a little hard to get it in one go.
yeah, that's fine. But whether you can uh, get the things that how you will recognize that which one is prime, which one is not prime, then what is full functional, what is partial functional, without thinking of the video lecture that I gave of full functional and partial functional. If you have not seen also, here you can understand that part I am asking whether partial functional, full functional is clear, whether the dependency how it is being seen is clear. As per the definition of 2NF, how you are relating, that is clear or not, those things. Because this part again I am stressing, normalization is very important. If you search through any year's get question from database, minimum 7 to 8 questions you will find. Any year get question you search, no doubt. There will be never a time where you will find less than 8 to 9 questions from database. And out of that 8 to 9 questions, 2 or 3 must be from normalization. That important this concept is. That's why I'm stressing it. From normalization, there are hardly 1, 2, 3, 4, 5 normal forms, okay? And you will get most questions from second and third normal form. One normal form is very easy because you have to just see the data whether that is atomic or not, whether there are three values or not. That's quite easy. That never asked. But two and second and third normal form, and determining the key, that is the crux of the syllabus, the entire syllabus. Very important. That's why again I'm stressing. In one class we will do 2NF only. There is no problem. The next class we will do 3NF. There is no issue. But any doubt anywhere, single point you can ask. We can again go through the things, because next I will just give you assignment, then you will do it or take it from somewhere. I will not get to know. But main thing is doubt clearance, whether you are getting this or not. Nobody will ask you the definition. What is the definition of 2NF? Nobody will ask you, or 3NF. They will just simply draw this kind of figures. Tell me how you are going to identify this is into NF or 3NF or something, something. How you can normalize it into NF. Those things will be asked. So that's why this is very important. Don't skip through or don't think that I will learn at a separate at a different time. I will go through the books, notes, video lectures. This is also kind of video lecture. So be clear. I'm stressing that. That's why. So tell me who else has now there are 23 people. Out of 23, one by one you can tell if you have doubt into NF or from here only. If you can see the screen, I am scrolling through the book. I am not sharing you the soft copy of the ebook because that might be a problem later. You can search it. Though I don't want any copyright issue, etc., etc. So you search it. Sixth edition or any edition. The books, the content of the books are almost the same. The most elaborative book on no, database concept. See this example. See this example 15.24. 15.24. Try to do it in 10 minutes. What you are getting, let me tell me. This has to be decomposed into 2NF. Consider the universal relation this where there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 attributes A to J. Set of functional dependency is given. A, B is determining C, A is determining D, E, B is determining F is determining G and H, D is determining I and J. Then first thing is what is the key of R. Your key is not given. Like in every schema you are getting the underlining will be given. You get to know that this is the key. But here key will not be given. You have to find the key. So how you will find the key? How will find the key?
Finding the by incorrect.
By finding the closure of the attribute. So say I am finding A plus. So what will be there in A plus? Let me if you have pen and paper with you, try to write it. Do it then tell me. First thing is finding the closure. Say I am finding A plus. Okay, this plus will be as superscript. Okay, this one A plus. What be A plus? Sorry. A plus means closure of A, in which attribute A itself will be there along with any other.
BC.
What will be there? A is deriving D and E, not BC. A is deriving D and E. So A itself will be there, D will be there, E will be there. Okay. Anything else you can get into this?
I and J.
IJ.
I and J. Yeah, because D is deriving I and J. So D itself is there already. I will be there, J will be there. Okay. Nothing else you can take. E is not deriving anything. No, nothing else you can take. So A itself will not be a key. Let me combine A and B. Say, oh, sorry. Yeah, fine. Closure of A and B will be A itself will be there, B itself will be there, A and B both will be there. Then combinedly it is deriving C, so C will be there. Then A already got D, E, I, J, so I can keep directly them D, E, I, J. Okay. Now B is deriving anything? Yes, F is there. F will come out. F is deriving G and H, so G and H will also come in. Anything else left? A, B, C, D, E, F, G, H, I, J. So all are derived. So this will be a key. This is the way you find the key. Okay. Any doubt in this case? How you are finding a key?
No, sir. No, sir.
Yeah. Fine. So this is one of the keys that are possible in the relation. You have to find all the possible keys. Okay, like combining. Suppose I combine A B. Now I can say C. Let's say C plus closure of C will be C itself will be there. Anything else I can keep in C closure? No, nothing. So this will not be an option. Now D, only D
I
will be there.
IJ.
IJ, D itself, I and J, nothing else will come out. This will also not be a key. Suppose I am combining A and D, maybe. Combining A and D, suppose A and D itself will be there. A is deriving D and E, so E can come in. D is deriving I and J, so I and J can come in. Then B will not come in anyhow. F will not come in. G and H will not come in. So this is also not a key. Okay. So likewise, you have to find all the possible combinations for getting the key. Okay, now A and C, A and C. A is deriving D and E. Unless and until you are having B with any of the combination, that is not possible to find all, because B is deriving F. No one else is deriving F. So you have to have B. Suppose I am thinking of B and C. Okay, then BC, BC will be there. Then F will be there. F will be there. F came in means G and H will come in. Then anything else? No, IJ cannot come in, D cannot come in. So someone got? Are you doing or all are watching on this? Anybody got any separate key apart from A and B? Say BD. BD is a potential option. B and D. B and D will be there. No, A cannot come in. A cannot come in. So it seems there is only one key here, AB, or there can be any other key. No need to think of combination of ABC, because AB is already a key, means ABC will be a super key only, or ABD will be a super key, ABE will be a super key. primary key will be only this. I cannot leave out A. I cannot leave out B from the key. That means this is the only key possible. Fine. So no need to think of other things. This is what is the key of R? That will be, the answer is AB. Okay. Now find out the dependencies, which is full functional, which is not full functional. Now let me write in terms of F1. F1 is what? A, B, determining C. F2 is A, someone is sleeping? No. B determines F. 4, F determines GH. 5, B determines IJ. Sorry, IJ. Fine. So this is your function dependency set given. AB determines C, F2 determines D, B determines F, F determines GH, D determines IJ. Okay. Now tell me whether this is as per 2NF or not. Okay or not as per 2NF.
Yes, sir. First one is okay, sir.
This is full functional dependency. So this is okay. This one,
No, sir.
this is partial functional dependency. Yeah, what I call. Yeah. So this is partial functional dependency. This is not okay. Okay. Now this one.
No, sir.
Partial.
This is, this is also partial functional dependency. Are you getting all? Because this was a key. Key means X side is a key means C is full functional dependent on both. Okay. Here D is partial functional dependent on the key because only A is there. There is no B. So if it is dependent, then it should be, if it is dependent on any of the key, it should be on both the attribute because the key content both the attribute A and B. It is only dependent on A. So that is this was that's why this is called a partial functional dependency, which is not okay as per the 2NF terms. Now this is also same. Here there is no A. Here it should have been a, if it would have been a here, F is full functional dependence on the key, but there is only B. So this is also partial functional dependency. Not okay. You have to reduce this. F G H. So neither this is a key nor these are anything, any prime attribute. So this is also okay because it, about this the 2NF does not say anything. Similarly, this one, these are all non-prime attributes. So this is also okay. Only thing is this one. So when you reduce into table into that means when you are sitting for 2NF normalization, when we are doing the 2NF normalization, then what will happen? You have to reduce this particular relation into what type? Whichever are okay, keep them as it is. Whichever are not okay, take them out. So let me take them out first. I am taking A. Oh wait, insert table column 3 rows 1. It will take some time. Don't worry. Yep. So what I will just copy this. So A and D, E are not okay, no? So I will remove them. I will keep them in separate table. Okay. Now A will be the primary key. So underline T and E will be now full functional dependent on A. This is not required. Fine. D and E will be the two non-prime attributes which are now full functional dependent on A. So in this case, there will be a functional dependency A determining D. Okay. Now next thing is this partial functional dependency B and F. Okay, keep here B, keep here F. These two are not required. Fine. Now B will be the primary key here. So F will be full function dependent on the primary key. So this is also okay. So for this will be the function dependency. Now rest thing which were initially all okay, these things. AB determining C, these will be as it is. AB determining C, F determining GH. We can have F here. F determining G and H here only. Then D determining IJ. So D was here, no? D determining I and J. Okay, so out of the A, B, C, D, E, F, G, H, I, J, you removed E only. Okay, this E was removed to separate table. Since B was determining F alone, they were kept in a separate table, but B will also be here. These are the primary key. Fine. So the answer to that problem is this. You normalize that relation into three different tables which are combined now in QNF. Still any doubt in QNF? Am I connected or disconnected? Hello?
Yes, sir.
Yeah, yeah, there. So it is fine. This was your 2NF concept. There are two definitions you have to remember. First part says about only primary key. You can always write the alternative definition because it is more generalized. It says dependency is on the any key of R, not only primary key. Okay, okay then. If you have no doubt, or I guess everything is clear. Let me take the attendance. Attendance is yeah, attendance is taken. Fine. So let's see when we'll see the third NF concept, transitive dependency. So if you have time, read the book. Okay, the book is very elaboratively given. So do the exercises also. Any doubt you can ask in the forum. Okay, okay then. Fine. I'm disconnecting.
So
Yep.